In another video, guys, it's all about GCSE and iGCSE math. This is Math with Daniel Dallas, and welcome back to Sets. Today we're gonna go through Venn diagrams, and we are going to consider problems and questions related to this topic. Okay, so if you don't mind, just grab your pens, grab your notes. It's gonna be a good practice for you guys. We are going to consider 3 problems related to sets and Venn diagrams. Basically, what you're supposed to do, you need to illustrate, show a piece of information using diagrams, and also that's going to be like easy, light problems and up to average, like in terms of complexity. So now you can have a look at problems starting from problem 1, and here's the problem 2, and the last one, problem 3. So try to fix all 3 problems. Try to do by round. It's going to be one more time. It's going to be good practice for you. And let's start doing with me. So we are on the first problem, and I'm going to have a little pre-setup. So we're going to put 3 circles in this case because we have 3 basically events, but in this case 3 sets A, B, C, because events is more about probability. Right now we just consider sets. This is the basic application of Venn diagrams for sets, and later on you can do that with events. Alright, so here we have universe of whole numbers from 0, not including 1, and up to 33. So we're going to consider the first set, which is represented by primes. So prime numbers, in other words. So I'm going to use listing, and in this case I'm just going to list elements. Alright, so primes starting from 2 and up to 33. So which primes we're going to include? We're going to include first of all starting from 2, then 3, then 5. So, and consequently we will have just odd numbers here, all right, in this chain. So 2, 3, 5, 7, next one, 11, 13, 17, 19, so next, and 20s, so 20, 23, 29, and 31. So 31 is going to be the final number in this row, and that's primes. Okay, they're the primes. Let's go to set B. I'm also going to use listing because in this case it's much better to use listing, and actually using Venn diagrams you can easily put all those numbers in the circle. I'm not going to do that for saving my time. Sometimes I just put some numbers which you can find in both sets, and that's why it's going to be intersection, so we'll see that soon. Okay, so just coming back to set B, we have both even and multiples of 5. Alright, so multiples is the numbers that can be easily divided by 5 with no remainder. Alright, so it's going to be a whole number because the universe whole numbers. Alright, so that's why both even and multiples of 5, the starting number is 10, then goes 20, and then we finalize using 30 as the last number. Okay, so set C, multiples of 4. So multiples of 4, again, numbers that can be divisible by 4 with no remainder. Okay, so we're going to use starting from 4, of course, and then goes 8. Every time we add 4, that's how we can easily find all multiples of 4. So that's why the next one's 12, then 16, 20, 24. Next goes 28. I just put it here, and 32 is going to be the last number. All right, maybe let's do like this. So 32 is going to be the final number in a row. So that's set C. What I'm going to do, I'm just going to circle the numbers that we will have in the intersection, basically common for several sets. Alright, so we're starting from B and C because obviously 20, my bad, so one more time, let's do that. So 20 and 20 here can be found in both sets. All right, what about primes? So prime numbers stays alone, they're like unique, and that means we are going to have set A as isolated circle. So that's why I just go to circles, and first we mark set A, that's going to be here, okay? So that's going to be set A. One more time, I'm not going to put all the elements that you can find in this listing. You just need to copy and put it in the circle. I just only show numbers for sets B and C. Alright, so what about B and C? I just switch the color. So that's going to be a set, say B, make it a little bit smaller, and let it be set, let it be set C. Alright, so here I'm going to put elements which are common, and 20 is the single element here in a row. So 20 I'll put here in the intersection. Just remember, intersection is common elements, and you can use this sign in order to mark, but it's not A, it's going to be B and C. B intersect with C. Smile down, alright? So that's going to be the only common elements. 10 and 30 I will set up here. That's going to be set B, and set C will comprise everything here and here. Alright, so every element, so 4, 8, 12, 16, and then 24, 28, and 32. Alright, so for set A we just put all this listing completely. And as you remember, outside within rectangle, because we're gonna use, we need to actually highlight all other elements that are not included in sets A, B, and C. So that's why outside the circles we will mark all the elements that left. As you can see, one definitely left. So what about 7, 8? So obviously 9, yes. So 9, 10 is not, 11, 12, 13, 14, alright. And so on. So you understand the logic, and the last element that you can find here outside is going to be 33. Just basically what you need to do, you need to again list all elements that are not included in sets A, B, or C. Alright, so that was short explanation for problem 1. Hope you understand that, and let's move to the problem 2. So right here, for A and for B and C and D, I'm going to use separate diagrams, as you can see here. So use the separate Venn diagrams. Okay, so for A, that's the general structure. I just put 2 circles in, and general case when A and B. So one more time, A and B, they intersect. Alright, let it be this way. Okay, so I'm gonna use this pattern. Let it be as the copy one. So one more time. So here's the pattern. Yeah. Okay, so, and I'm gonna use, okay, so one more time, let's try do everything here. Oh yeah, that's much better. So 1, maybe just diminish a little bit. So here, so one more time, here you go. And the last one. Oh, okay. Alright, so it's done. And now I mark just letters A, letter B, B, C, and D. Alright, so we're starting from A, and we have events A and B. So the general case when they have like something common and something different. So in A or in B, but not in both. So the both part means the intersection, so that means in A or in B. So just shade those regions. As you can see, intersection just left unshaded. Here is also unshaded, this small rectangle. So outside circles, we don't include this region. So B part, A intersect with not B. All right, so let it be A. Here is B again, and common part of A with not B. So first of all, I'm just going to shade not B region. So not B region is this part means only A, okay? This not B, and also here. All right, so now we need to have intersection with A. So intersection is common part. So A is this one. Okay, so intersection is only when this type of shading, like pink one, intersect with the yellow one. So that means that's going to be this region, except for the common part and except for beyond the circles. Okay, that's going to be B. Let's go to C. A intersect with B and not. So this one more time, this apostrophe means that you negate and make the opposite, or making the complement for what you have inside the brackets. Okay, so for C, we're gonna have A intersect with B. So here is again A, here is B. Intersection is only the common part, but now you're making the complement, so everything outside. So everything outside I will shade with this one, so the answer is going to be this sort of shading. So that means outside is here, and of course the rest part that you can find here outside the circles. That's going to be the answer for C. Alright, so let's go to D. Here's A, here's B. Now you need to find not A intersect with not B. So what I'm going to do, I'm going to first shade what not A means. It's here. It's just only B. And this part also. So beyond the circles, outside the circles. Not B, it means only A. And again, this part, which I shade in maybe this part, this sort of shading. So that's why I'm going to use this part and also this part. Okay, maybe too early words for yellow shading for A, so that's why I'm just going to use shading for only A as the pink one. Okay, that means not B. All right, and this part not B, everything outside the circle B. All right, it's also here. Now we're going to consider common parts. So intersection is always where this sort of shading intersect with yellow one. So that means this is A intersect with not B. And that's going to be a solution for D. So hope you understand that. If you did it, let's go to problem 3. So for problem 3, I'm going to use for A, I'm going to use the following. So I'm going to use preset again. So in this case, A intersect with B and the complement for this. So that means let it be A, let it be B, and we're gonna just mark intersection. So here is intersection, so that means the complement for intersection is going to be everything outside. Okay, so it's going to be this one, and also the complement is going to be this small part outside circles. So this is A intersect with B and not. So I'm going to use the next diagram, like similar to that. And I'm gonna use again 2 circles inside there. Alright, the first one and the second one. Okay, so A, B. Now we're going to mark not A, so that's why I'm going to use this type of shading. So not A is everything except for A itself. Okay, so it's B part and also this small part outside. Okay, that's not A. I'm going to use another type of shading, let it be this one, and I mark this type of shading for not B. Alright, so not B, it means everything outside B, so it's just only A and also here. We're going to use intersection, so intersection is combination of two types of shading, and that means it's going to be not A intersect with not B. As you can see, there is the quite significant difference. So here, it's the only common part for A, not A intersect with not B, while for A intersect with B and the complement for this, it's much wider region. So that means this operation, when you're trying to use operator of the complement, is not equal, so is not equal to not A intersect with not B. Alright, so that means we prove, and let's move to the part B. Okay, so here's part B. For part B, we're going to use 3 different circles, okay, A, B, and C. So let's set up, okay, let's take again Venn diagram, and let's put 3 circles. So that'll be circle 1, so circle 2, and circle 3. Okay, so let's mark them as A, B, and C. So right now I'm going to consider the left hand side, so that is going to be this one. I'm just wondering, can I copy that? I hope I can. Yes, that works. Hopefully. All right, except for letter A. Okay, so let it be this for the left hand side, and this is going to be for the right hand side. So B intersect with C. I'm just going to use this type of shading. So B intersect with C. I'm going to use this type of shading, and this is going to be, B intersect with C in this part. So only common for B and C only, not for A. So however, it takes a bit of the region of A. Okay, so for union with A, so A union, I'm going to use, so for A, just only for A, I'm going to use this type of shading. So that shading is here. And now we are going to unite. So that means we're going to combine both this type of shading with dark blue shading. So combine means we add them simply. Alright? And that means the resultant shading for this part is going to be this one. Okay? Everything here and this part here as well. So we are not going to consider any rest part, means outside the circles. So that's the left hand side of the equation. So on the right hand side, obviously we need to get the same type of shading. So that's why, first of all, I'm going to consider A union B, okay, A union B, and I'm going to use this type of shading. So A union with B, so that means we're gonna shade the whole A with only B. All right, so that's going to be this type of shading, yellow one. And let's use dark blue for A union with C. So A union with C, we're going to use this type of shading. So A and C again, it's here. So here, A union C. Now only A, okay, only A. Okay, so that's going to be superposition of A and C, and this is going to be a union. All right, now we're going to have a look for intersection. This smile down means intersection, so we're going to check only intersection where this yellow shading intersect with dark blue. And actually I'm going to use just one more time to confirm. So for union of both type of shading, I'm going to use this red one, and obviously where yellow lines intersect with dark blue, so that means it's going to be this region here, here as well, and the small part. Now comparing with the left hand side, we definitely have an equation or equality between two pictorial diagrams, so that means we proved it graphically. Okay, and the last part, so C for the problem 3, I've prepared a little preset, again a left hand side, right hand side, but graphical equation, and the main question is to find out whether they're equal or not. So we need to prove they're equal, verify, so that means we're pretty sure that it should be equal. That's sort of the hint. Okay, so let's take this sort of shading for B union with C. It's everywhere here. Union, it means both in B and C. Okay, I mean it's in A, sorry, it's in B, C, or in both. That's much more correct. Okay, so that's why I'm going to use this type of shading. Hope you understand that's the union. And for the rest part, for A, intersect with this part, I'm going to use this sort of shading. So intersection means A, where A has the common part with B union C. Alright, so that means this type of shading along with yellow one will represent the left hand side. So this is the left hand side. Okay, so what about the right hand side? A union C, let's combine that. So A union C, let's use this type of shading, it's much better. So sorry, A intersect with C, A intersect with C, it's only the common part of A and C. Okay, while A and B, it's common part for A and B, so because it's again intersection. Okay, so and because we are going to unite them, so we are going to consider both types of shading. So A intersect with B in combination of red one, red shading. Okay, so maybe proper to take this one. Okay, so that's going to be a red shading or a pink one. Okay, so that means we definitely see that this here correspond to this one because we're going to combine the last one. So graphically they're the same parts. That means there is no doubt in it. Okay, so there is no doubt. All right, so hope you understand that. It was complete explanation how to use Venn diagrams, how to solve graphical equations, how to verify different equations graphically or verify that's not true, there is no like correspondence or there is no relation between them. Okay, and hope you like that. That was good revision. So compare your workings, compare with mine, and subscribe if you're new here, of course. So like this video, put likes, share the comments, and just see you next time.